Now in this video we are going to talk about weightlessness in a satellite. Now you must have seen the video clips where the astronauts, for example Rakesh Sharma, who had been to space in 1984, we all saw that video, okay, and those astronauts, they were floating over there in the spaceship there, okay, and so that means there is no gravitational force acting on them. That is what we felt here. But then is it the fact? Okay, now first of all let us try and figure out how we and why we sense that we have some weight. Okay, now I'm standing on ground, my body has got some weight, okay, so that weight is getting exerted on the ground, okay, and the floor or ground is giving me a normal force, normal reaction force, okay, and then because of that normal reaction force I am feeling my weight, okay, the skin of my feet, okay, it gets pinched between my weight and the normal force, and that is how I get a sensation of my own weight, correct. But now let us imagine a situation wherein I'm standing in the cab of a lift. You must have seen the lifts on construction sites. Those jib cranes are there like this, okay, and there is that cab over there, and I'm standing in that cab. Now that cab is connected with the crane by means of a rope. That rope runs over a pulley, and then that rope, after passing over that pulley, it is wound on the drum, okay. Now now when I'm standing on the cab, my feet are exerting my weight of my body on the floor of the cab, correct, and now there is tension in the rope, correct, which is pulling the cab upwards, okay. Now the reason is, now since I'm able to exert my weight on the floor of the cab, I'm feeling that I have some weight. Now just imagine that the rope breaks. Now what happens? If the rope breaks, then that cab starts going down with acceleration of free fall. My body is also going down with acceleration of free fall, right? So both my body as well as the cab or the floor of the cab, they are going down with the same acceleration. So will my body be able to exert any force on the floor? It won't be possible, because this is that floor and this is where I am standing there, correct. So this is going down with G and my body is also going down with G. I won't be able to exert any force on the floor of the cab. So if I am not exerting any force, will I get any normal reaction? So unless I exert some force on the floor, I won't be getting any normal reaction, and then I won't feel my weight. Now same is the case with this spaceship here. Now this astronaut is standing here in the spaceship, okay. Don't worry about the shape of the spaceship, okay, it's going to be different, okay, and then we have Earth here, correct. Now this spaceship, it is experiencing this G here, whatever G at that height, and then this astronaut is also experiencing the same G, correct. So in short we can say that both of them, they are in a free fall towards the center of Earth. So now if acceleration of both of them, if it is same, how can the astronaut feel his weight, right? So that is the reason he feels weightless in the spaceship or in the satellite. So that was about weightlessness in a satellite. In the next video we are going to talk more about variation of acceleration due to gravity because of height or depth. Now when I say height, it is the height at which the satellite is located above Earth's surface. When I say depth, I'm going below the Earth's surface. So we'll be discussing that in the next video. Thank you.